Josh, hey, thanks a lot for coming for our
thanks for picking me up.
In the car, right? It's kind of been wild. So we wanted to talk to you a little bit about, let's start with the, Contributors.
Contributor Summit, yeah.
Summit.
Yeah, so one of the events that always happens at the beginning of KubeCon is the Kubernetes Contributor Summit.
Right.
So this is run by my SIG, my committee in Kubernetes called SIG Contributor Experience, in order to have a place for Kubernetes contributors, in this case it was 150, 200 Kubernetes contributors to get together and discuss what they're working on in all sorts of different ways. So we had discussions about the process of proposing major changes and discussions about whether or not we should change the platform that we use to publish the docs.
Okay.
And a big discussion in one of my personal favorite areas, which is stateful applications in Kubernetes.
Gotcha.
Because that's always been a bit of a challenge.
Yeah, yeah.
Although, frankly, it's been a bit of a challenge because stateful applications are always a bit of a challenge.
Right. Yeah, the whole reason for that HTTP thing was to try to avoid that.
So everybody gets together and we have all these different discussions throughout the day about, and honestly, for a lot of people, it's just a chance to meet face to face because, you're on Zoom calls on chat with somebody for like a year straight. Right, totally. And it's really super helpful for seeing people face to face. Somebody from university actually did a study, and this was around, I think they covered the Linux and MySQL and PostgreSQL communities because it was back in the aughts. Right. And they showed that the number of arguments on mailing lists decreased dramatically for like 3-4 months after an in-person event.
No way, really?
Yeah.
Oh, that's so interesting. I still remember, and this is, but I still remember a guy I used to know who worked on a remote team. Team was all fully remote, and this was like 20 years ago. So it was really unusual to have a remote team, but it was at Oracle, and on a quarterly basis, part of their commitment to, because they wanted this team to exist and be remote, was that on a quarterly basis, they put them all together in the same place for, a week, I want to say.
Yeah.
And I think it makes a huge difference just to, get some of that in-person thing, especially if you've never physically met, it's even harder.
Yeah, part of it is, honestly, it's just easier to trust other people if you've met them once face-to-face.
Yeah, no, I totally get that. It is, and I think that's one of the things we're really experiencing, with the pandemic and everything else, that we're starting to get the hang of. Well, that's cool. So tell me some more about stateful applications. Aside from they are a pain in the butt.
Yeah, well, it's a pain about so we were actually discussing this in the session, that sort of thing, talking about things that we still wanted to do in Kubernetes for stateful applications, because we had sort of a couple first cuts, which is stateful sets and CRDs and operators, but nobody's really satisfied with that because there's a whole bunch of problems with real life stateful applications that it doesn't leave solved, right? Because, first of all, they're all different kinds of stateful applications, right? Databases get a lot of press, right? But file storage, caches, information stores, authentication stores. There are a whole bunch of other kinds of stateful applications that have different needs from databases, and databases have different needs from each other. Right. So you need this huge amount of customization, which led us to things like CRDs and operators. But the problem with an operator is that you are basically writing your own infrastructure software, right, or using something written for somebody else to attach that to Kubernetes, and Kubernetes is not really providing you with a framework except a place to attach that plugin. Right. And so, as a result, we have this whole marketplace of database operators and other stateful applications operators that are in what we call in the operator framework level 1, phase 1, right? Which is its sort of initial cut that is usable in production, but it's missing a lot of instrumentation and maturity and lifecycle management and that sort of thing. And so the feeling really is that we should come up with a way within Kubernetes for Kubernetes itself to supply more of a framework for those other things.
Right, right. Yeah, actually be more involved with the infrastructure for operation, in a sense. Yeah.
Yeah, and so one of the things I was thinking about is somebody who is a longtime stateful applications person with a long history in databases.
Yeah, right.
Is that part of the problem here precedes Kubernetes, right? Because if you look at before Kubernetes existed, before Docker existed, the stateless applications were already being fully automated through configuration management. And so in a lot of ways, moving those applications to Kubernetes was just a matter of porting the existing patterns we had in configuration management into the new world of container orchestration.
Right.
The stateful applications were not being automated by configuration management as a rule.
Right.
And so there was no previous implementation to port.
This is why you had so many database administrators who were really specialized in a particular database and everything else. Yeah.
It was a harder problem, right? It was the reason why it hadn't been done yet was people were like, let's solve the easy problems first, which is exactly the right thing to do.
Right.
They just hadn't gotten to the really hard problems yet.
Yeah, totally. And so you think that, so how, or do you have any ideas about where that might land? Like how would Kubernetes get more involved in kind of those stateful components without losing its own flexibility?
Yeah, well, there's a lot of sort of separate areas to address. One of the ones that I've personally worked on is resource management, where I'm working with the people who are in runtimes, right? Because now we have cgroups v2, we have more control over resource management on the individual machines, but at the same time, and this is another meeting at the Contributor Summit, right? The runtime people all met up, and by runtime I mean like Cryo, Containerd, etc. They all met up to discuss future direction of runtime, and part of that was where should resource management live? Because a lot of how Kubernetes interacts with the container runtimes was built around Docker, and a lot of that was some really ugly workarounds because Docker was not designed to be controlled by an orchestration system. Now that Docker is no longer supported, they can get rid of those workarounds, and so the runtime people were discussing, okay, if we're getting rid of these workarounds, what should we be doing instead? What does right look like? So I mean, it's funny because people outside Kubernetes look at it and they're saying, okay, Kubernetes is being used in production in a whole bunch of places. You can use it to run a cluster with thousands of nodes, etc. Most of the big problems are solved. People are moving on to doing platform engineering and developing stuff in a stack above Kubernetes, right? So Kubernetes should be in maintenance mode now, and it's really not true, right? Because now we're getting to the stage of it's time to refactor all the things that we tried 3 years ago that turned out to be bad decisions.
Right. Or in kind of to your earlier point, right? Also get to some of the hard stuff, right? You made decisions early on to let's avoid this problem for later, and now it's probably a good idea to actually address the problem. I think that's one of the things that I think is I appreciate about the Kubernetes project, and is one of those problems that you see in a lot of mature projects is okay, when you're mature, do you recognize the fact that doesn't have anything to do with being done, or do you kind of just keep making your mature thing faster, right? I appreciate that. I think Kubernetes in a lot of ways is saying, okay, we've got a certain level of maturity, now let's go back and address the next problem, not how do we just refine the thing that we have. Which is, I think a much preferred route, at least for me. But,
well, and I mean, I like Kubernetes' approach, right? And it's honestly one of the reasons why Kubernetes kind of won out over Mesos, was that Mesos immediately went for the hard problems. But the difficulty, the problem with that was you had to be a computer scientist with a PhD almost
to contribute at all.
In order to use Mesos even for simple tasks, out of the gate, because it was addressing the really high-end use case. There wasn't a gee, I have 5 nodes and I just want to run containers across those 5 nodes, right? It was with Mesos, you were instantly going for the 1,000 node cluster.
Right. And oddly, I thought with Mesos actually is that, and it felt like they were targeting the individual developer in their early stage, like, here's how to get started or whatever. And I was always very much that, in the sense of, I feel like I'm doing a really heavy lift to get my stupid thing to run.
Yeah.
And I don't know, I just always thought that was kind of interesting. But yeah, so Kubernetes has been doing some interesting stuff there. What was, we were going to talk about, we were going to talk about history of Kubernetes a little bit.
Yeah.
Which I think would be kind of interesting, because now, right, we're kind of saying, okay, here's the next, almost like the next stage of Kubernetes.
Yeah. But
if we talk a little bit about what happened before, and we're, at least I was joking around about, I've been doing container stuff since like 2012. I think it's funny that you don't recognize that you need orchestration until you've like shot yourself in the foot a bunch of times with containers already, and then you're like, oh, now I get it. So how do you feel about it? What's your interesting stories about the history of Kubernetes?
Well, so one of the things for a lot of people listening to this who got into Kubernetes later on is that, if you look at it in retrospect, it was obvious that Kubernetes was going to win and become the default orchestration
It certainly
system.
Wasn't at the time.
Right? It definitely wasn't at the time.
Yeah, I really thought Swarm was really going to take it for a while there.
And, so here's one of the things, because it was one of the goofy things, right, is that you had Swarm, which was making a developer-friendly play, right? Because that's what Docker was good at.
Right, exactly.
And you had Mesos, who was coming in from the high end, right? Is we're going to run all the workloads, including the hardest thing. We're going to replace Singularity, which was an orchestration system specifically for HPC. And that sort of thing.
Yeah, I've never worked with that. I think I've heard of it.
And Kubernetes was in the middle. And the thing is, if you're in the middle, you never know if it's only history tells you is that the happy medium or the undesirable middle, right? Because if you look at it a different way, like, for example, if you compare this to my history of databases, right? When the new non-relational databases emerged on the scene, like MongoDB, etc., it put MySQL in a bad position where they were kind of sandwiched between MongoDB and PostgreSQL in terms of their market and being and losing users from both sides.
Right.
And that could have been Kubernetes, right? But it turns out that Kubernetes was the happy medium, right? It turns out that, in fact, Kubernetes was giving people just enough orchestration to solve the problems that they had in 2016. And Mesos was too hard and too complicated, and Swarm was too limited.
Right.
And things could have gone a very different way. I think if DCOS had come out much earlier than it did, that might be what we're using now. Because that was actually pretty nice. They solved a lot of the sort of UX problems that Mesos had by providing an implementation of Mesos that satisfied a very common use case.
Right. It's one of the things, actually, I've talked about in a bunch of these interviews, is like one of the challenges, I think, that people who are deep, dark inside of like building, Kubernetes or whatever, is that it's so difficult to wrap your head around when you're building distributed systems. Not having a visualization is very, very difficult, because the goal is that you don't really know how the whole thing works. And sometimes as an engineer, you kind of need to get a tighter picture than that. But generating that from a bunch of YAML files is very difficult to do conceptually.
And I don't know the solution to that, because the problem is that the visualizations and the abstractions
are
helpful, but they're also damaging, if you follow me.
Right, because the problem is, I think people look at them as almost like reliable when they're not really. They're more like a hint about what's going on, not necessarily what's going on.
Right, and
it's like Schrodinger's cat.
Well, and we have this problem all the time with relational databases, right? Is that people would use entity diagrams, right? or other ORM tools as their way into the database. And that was nice, but that's not how the data is actually being stored.
Right, right.
And sometimes the gap between your representation and how it's actually happening, and particularly there's a tendency of abstractions to reduce distributed computing to sequential, to procedural logic.
Right.
Which it really isn't. It very specifically isn't.
Or if it is, you're doing it wrong.
Yeah, and this actually goes back to one of the hard things to teach people, which is, how do you teach people to really understand concurrent execution?
Right. Yeah.
Because that was always, it was in the database world, that was a battle for us, because all the time people would be saying, oh, well, I'm trying to debug it, and this transaction is doing this, and this other transaction is doing that, next. And I'm like, no, there is no next.
Right.
Right? You have 16 cores in this machine. Those are happening at the same time.
Right. Right.
And you can never actually determine the order in which they happen in any reliable way.
Right.
And then when you throw that across a whole bunch of computers like we do for Kubernetes, that's really true, right? Because you don't even have, unless you have a very expensive setup, you don't even have clocks that you can rely on with any level of precision, right? If you're really looking down at the microsecond level, you don't know what order things happened in, and that really needs to not matter. But it's hard for people to wrap their heads around.
And this is the funniest thing I find about this too, is that people also have a really hard time getting their head wrapped around event-driven architecture. Yet, event-driven architecture actually simplifies most of this conversation,
right? Because
you know the order of things, because it's by when the event occurred. So you don't necessarily know whether this event occurred before that event, but you know that when this event fired, this thing happened, and then when that event fired, that thing. So I don't know. I find it easier to wrap my head around a distributed system when you think about it in terms of events, rather than a series of services that call each other.
Yeah. Well, at least up until you need to debug something.
Well, right, and that's
particularly something involving a lock.
Right. Yeah, exactly. Yeah, I remember those nasty things in databases as well.
It is the hardest thing, because I fixed a number of bugs in Postgres involving lock handling, and the narrowing down the actually having to figure out the simultaneity of it in order to figure out what was going wrong.
Well, and or like, what's the cheapest lock you can get away with?
Right.
That's the other big part of it. Looks like there's a race happening over there.
Yeah, there is.
We did go by a soccer game. Earlier, which I appreciated.
This is awesome.
Yeah.
This is really nice. So thank you for taking me on this drive, because Belle Isle was kind of my list for Detroit.
Yeah.
And I did not get over here on Saturday.
Well, here you go.
So that's and that becomes a hard thing, right? Because that is honestly right. There's a lot of, sort of UI complexity for Kubernetes, right? Because honestly, we're just getting away from the whole stage of developers writing YAML files, right? Which is really not where we should be in terms of developer interface, right?
Right.
The developers should be writing stuff in their own languages, and the YAML file should be produced by a tool.
Right.
Totally. And we're getting that, right? Because we now have all kinds of UIs and code ready, and we have now people are getting into serverless stuff, and which provides a more developer-friendly layer there, right? But that doesn't take away from a developer. Particularly, right, if they're now getting into Knative and serverless and event-driven programming, needing to wean themselves off of sequential thinking. Right.
Yeah, I still remember a guy I've worked with. It's funny. He's worked for me. I've worked for him. We've been peers. It's kind of weird how that. I don't know about you, but I never expected that kind of thing to happen in my career. But it's like I've had all of these relationships with this one person, but I still remember him giving me a super hard time because of I had a racing thread problem in some code I had written, and it was like, and he was like, what, why did you do this or whatever? I was like, yeah. And I'm looking at it and I'm like, and past me was apparently an idiot, because I looked at it. I'm like, yeah, there's obviously a race condition right here. It's just always like, wrapping your head around actual stuff that is, truly multi-threaded or simultaneously executing or whatever it's super hard, and it's just so prone to error, and it's also very difficult to test, so I think that's also part of the challenge. So you're enjoying Belle Isle?
Yeah.
Did you notice? I don't know. Oh yeah. So there's a lake in the middle of the island,
yeah.
which I think is weird. Because if you think of an island, I expect there to maybe be a pond, but I don't know. A lake seems too big to be in the middle of the island.
No. Because really, if you think about it, we think of like land and water as being separate, and that's like a bathtub.
Yeah. Right.
But really, what we're seeing there is the exposed water table.
Yeah.
Right? As in, if I dug a hole underneath this road that went down by 4 feet, it would fill up with water.
Right. Totally. Yeah. It's actually the other way around, right? It's the land poking up, not the water, filling in.
Yep.
All right. So talking about KubeCon, so you did the Contributor Summit.
Yeah.
That was yesterday, right?
Yeah.
I don't know what day it is.
The day before that, I did a little event called Cloud Native Rejects.
Okay.
It's a fun little event where talks that were not accepted for the main KubeCon can apply to go there, and they pick a sort of curated group of talks.
Nice.
And we go see them. And for somebody who's very involved in running KubeCon as a show, I really enjoy Rejects simply because I don't get a chance to attend a lot of sessions at KubeCon.
Yeah, right, totally.
Because I'm just way too busy with so many other events and meetings and needing to run things and booth stuff and a bunch of other stuff. So, plus, Rejects can have things that maybe don't have as broad appeal.
Right.
But as somebody who's involved in cloud native development, are much more interesting to me personally, right?
Yeah. It's funny. As the more I get into something, I start to be much more interested in the more esoteric stuff.
Yeah.
I think because it's like that's the stuff I haven't even thought about yet. I don't know. It's cool. I completely agree. I gotta check this out. I don't think I knew about that.
Yeah. They'll be having ones before Amsterdam and before wherever we are next year in North America too.
Yeah. Cool.
So
that was Sunday?
Yeah, it was Sunday.
Gotcha.
And before that Saturday, I went to the Van Gogh exhibit.
Nice.
At the Detroit Institute of Art. It was awesome.
Yeah, I really wanted to go.
It was really amazing.
Yeah. I've heard very good things about that art museum in general.
It's a really excellent art museum in general, and this exhibit was, I think it's the biggest exhibit of Van Gogh's work that has ever toured the U.S.
Yeah, it's touring. Right? I think it was either in Boston or it's coming to Boston.
Yeah, I think the museums are getting it are the ones that actually have artworks that are part of the
collection.
Right?
Gotcha. Yeah.
So
so they'll loan them out.
Yeah, so it would not have. It's not coming to Portland, for example.
Right.
So
okay.
This was my one chance to see it.
Yeah, that's awesome.
And so then today is other sort of co-located events, etc. For me, it was a whole day of meetings.
And one interview in a car.
Right. And then I'm going to be going to the reception for OpenShift Commons.
Yeah, I think we're both going to that. And we're going to talk about, and I guess, are we like kind of answering questions, or are we just kind of saying this is the table for this thing, or?
Yeah, no, it's for discussions. It's for discussions, right?
Yeah.
There's a lot of people there who are implementing things.
Right.
And they'll have questions, right? And maybe somebody will have questions about stateful applications in Kubernetes.
Right.
I'll field those, right?
Exactly.
And then the rest of the week is kind of main Kubernetes. So, or main KubeCon.
Right.
Which
are you giving a talk?
Huge. I am not this year, which I am just chuffed about.
Yeah.
Because
I can't, like, when I run the little conference I run, the DevConf, like, I can't imagine trying to give a talk at that thing.
Yeah, no, but I had a lot of fun. I coached 4 or 5 different speakers for this KubeCon.
Nice.
Of whom 3 are brand new speakers.
Cool.
I really enjoy doing that, and I really enjoy us, having new speakers, right, and not just the same people, giving talks all the time.
Yeah, no, I definitely agree with that. It kind of goes back to, I was talking to somebody earlier, Savita maybe, about, it's like I think inclusion is important and a really good thing, and it provides a lot of new perspectives. But in some ways, it's also kind of selfish because, like, I want all of those new perspectives because it helps me.
Yeah.
Right. Like, and you know, and like you talk about like a new speaker, when you have a brand new speaker, whatever, they're coming with a new perspective that I may not have thought of before when they present, you know, some content that maybe I understand the content, but they're coming at it from a different lens, you know, and it just doesn't, you know, so I really like that.
And it gets really important when we're entering whatever we're on right now, year 7, something like that, of Kubernetes.
Yeah. Right.
Where, like, we know that there were a bunch of assumptions built into Kubernetes originally that were circumstantial, right? And you know, we had talks in Contributor Summit and stuff about, you know, ripping some of those out. But we're so used to them, we're not going to recognize all of them.
Right, for sure.
And having a new person show up and saying, you know, hey, we could just do this thing instead.
Right.
And we're like, well, you know, that hey, wait a minute. Yeah.
Right. Yeah. This thing is dumb. It's like that race condition, right? It's like, you know, even if it's past me versus future me's perspective, it's still a different perspective. But yeah, when you have, I mean, so, you know, the kind of the beauty of open source, right, is the you know, the many eyes thing. You know, but you've gotta, there's a little bit more to it than just saying, you know, many eyes. You know, you actually have to make it possible. Right. You know, for them to do it. And, you know, and the problem with big, you know, industry conferences, right, is they want to draw a crowd, you know, whether they're making a profit or not, it's still like, you know, a business, right? You want to have when you run a conference, you want to have a group of people who want to come, right? And the way you get that is by having big name speakers. So it can be really difficult to also include, you know, brand new speakers, but otherwise you never get any more big name speakers.
Well, and one of the things I've liked about KubeCon is, even as much as it becomes sort of a large commercial conference and stuff, they have stayed dedicated to inclusion and trying to attract new speakers and everything else. Because like 2 of the new speakers I was coaching are actually going to be giving keynotes.
Oh wow, cool, nice.
So the you know, and that's not taken for granted, right? I remember back when I was working with some of the old IDG conferences and stuff.
Oh yeah.
We had to fight them tooth and nail to get them to include anybody new.
Right.
And so I really appreciate that as sort of a tenet of the sort of spirit of KubeCon, right? Is that, you know, we are going to have change and we are going to have new people.
Right. Well, it's, you know, it's like, how do you get the next, you know, big name speaker if you don't give any opportunities to new people, right? Yeah, it's that's one thing I think KubeCon is really interesting for. I mean, you know, you even see it in the CFP process of like, you know, hey, you know, they ask you a lot of kind of relatively detailed questions about how, you know, how is this going to widen the Kubernetes community essentially before they're going to choose your talk at all, which I think is pretty cool.
One of the other sort of interesting things on the horizon that you'll see happening in the KubeCon program and stuff is WASM, of course.
Oh, right. Yeah, totally. Really interesting.
Yeah.
That's one of those things where, I don't know, do you remember when aspect programming first started becoming a thing? Yeah. You know, you see it. It's mostly in Java these days, but it's the same kind of concept with WASM, or can be. That's one of the models, right? Like Envoy uses is basically, they're essentially doing aspect programming except using WASM to deliver it kind of along the wire. But kind of WASM being everywhere has some really interesting possibilities and characteristics, like outside of the Kubernetes world as well. You know, just like, you know, your browser being running a like on the fly compiled language is interesting, you know. But so is there anything specific coming up with WASM that you?
Well, because right now, because we're talking about, because obviously for this conference and that sort of thing, part of the concern, you know, thinking about this is like, hey, you know, what about server-side WASM, right? You know, WASI and that sort of thing. And then how do we run that on Kubernetes? Because we just had this whole like discussion with somebody at Regex who's working on one of the WASM-based platforms.
Okay.
And you know, and they were talking about some of the problems that they're trying to solve for server side, and I'm like, Knative actually already does all of that. It kind of feels like we just need a way for Knative to run
WASM.
Yes,
Yeah.
to run your WASM because then you can just make use of their code to do all that management.
Right. Right. Yeah, that seems very plausible.
So, because ultimately, obviously, Kubernetes is designed to run containers, but not exclusively containers.
Well, right. People are, the people are running VMs in it, right?
Right. Yeah.
So
containers are the abstraction that we have.
Right.
And there's a lot of trying to reduce it to something that looks like a container.
Yeah. Yeah.
But that's one of those things that you reevaluate all the time, right? We're
Right.
talking about reevaluating runtimes and stuff. Is like, well, how much does it have to look like a container?
Right.
And can we make other things look sufficiently like containers?
Right. That they
particularly, and not make it like bespoke, right? Not make it
right,
something
of
that has to
course,
be hand configured.
Right.
And up until now, there's been a lot of focus on doing that with VMs, right, from the other end, because there's times that, you want to use a VM rather than a container.
Right.
Not just, a lot of focus has been in the legacy use case,
Right.
Where you have applications that are already optimized for VMs. But there's also other use cases where,
if you want vertical
among
scaling,
other things, right, you want vertical scaling, you have very rigorous information security requirements,
Right, yeah.
where you need to have something that doesn't have side effects.
Right. That's why I really like NARCs. Have you seen the NARCs?
And for that matter, right, if you want to link into CPU level encryption,
Right.
All of these sorts of other things. But there's no reason that we can't do this at the other end, right? And look at things like WASM and stuff and say, okay, well, on the one hand, we can go sort of heavier weight than containers and have VMs that Kubernetes treats like containers.
Right.
Or pods. It tends to treat the VMs more like pods. But what about taking, basically a binary executable, which ultimately a container is an executable.
Right.
And
well, especially with the more modern runtimes, right?
Yeah.
Where it really is just another process.
Right. And have Kubernetes orchestrate that as well, right? Because ultimately, the core of Kubernetes is an API and a scheduler for a cluster.
Right.
And a lot of ways you can think of it is, hey, we're replacing the Linux CPU scheduler, and we're just doing it across a cluster of machines.
Right. Right. I will say that's one thing that I'm at least that I'm aware of. Right. There could always be lots of stuff that I'm not. But I don't know of a lot of people who are working on kind of new, interesting schedulers for Kubernetes. Taking into account what came up earlier, actually, if like everybody starts their day at 9 a.m., so we want to do some sort of predictive modeling so that we spin up a bunch of engines before that, so that we don't have a slowdown during login time.
People are waiting for some stuff to merge.
You think? Yeah.
There's been a ton of work on what's called the scheduler framework.
Okay.
Because previously, in order to do your own custom scheduler, you were forking the main Kubernetes scheduler and writing your own in Go.
Right. Right.
And the scheduler, SIG scheduling, said, people are interested enough of this that we really want to make it possible to do this by basically plugging in a bunch of algorithms, and changing weighting on things and changing configuration and that sort of thing to make it more possible to modify the scheduler in small ways. And hence the scheduler framework.
Getting back to that just bespoke problem, right? It's the same thing that operator is having, right?
But it's a natural transition, right? Which is you start out with a bespoke thing that involves writing a bunch of Go code, right? And by people doing the bespoke thing, you figure out what it was you needed to implement.
Right, exactly.
And then you have a new generation, and in that new generation, people do. We make it a little bit more systematic and a little bit more reproducible. So,
yeah, I totally hear. Well, thanks so much for being on the show and taking the ride around Detroit with me.
It was very enjoyable. Thank you for showing me Belle Isle.
Yeah, it was definitely